Okay guys, so welcome ulit sa ating YouTube channel. Ito na yung lesson 33 sa ating complex analysis. So ito na yung chapter that is all about application ng power series sa integration. So integration pa rin tayo literal, pero ito na yung way na kung saan i-apply natin yung power series. So gagawin muna natin power series yung integrand o yung f sa loob. Yung diba sa loob ng integral, meron tayong integrand. Yung integrand, that is the function. Yung function, gagawin natin siyang power series. So specifically dapat Lorentz series. So bakit sa Lorentz series? So sa Lorentz series kailangan natin kasi siya ay parang may annulus. So siya ay something may residue doon. So si Lorentz series lang yung tanging may residue. Okay, so mamaya malalaman nyo bakit ko kailangan gawin Lorentz or kailangan natin ma-obtain na dapat siya ay Lorentz. Okay, so definition. So a point z0 is called a singular point of a function f if f fails to be analytic at z0, but it is analytic at some point in every neighborhood of z0. So a singular point z0 is said to be isolated if there is a deleted neighborhood 0 less than z minus z0 less than epsilon of z0 throughout which f is analytic. So ano lang ibig sabihin? Singular point z0 into which yung function is not continuous or not analytic. So ano ibig sabihin nun? So for example, 1 over z. Kung 1 over z, yung ating singular point is 0. Okay, kasi dun lang magiging undefined yung function natin sa 0. So therefore, yung singular point niya is 0. So paano natin kukunin yung singular point ng isang function? Ganito lang kasimple. Kung siya ay fraction, okay, more specifically talaga dito fraction eh. Kung siya ay fraction, equate mo lang yung denominator sa 0, tapos kunin mo lang yung zeros niya. So tulad nito, the function z plus 1 over z cubed plus z squared plus 1. So kung napansin mo, siya ay fraction, so may denominator siya. Equate ko lang yung denominator sa 0. So ang gagawin ko lang, so we have z cubed plus z squared plus 1 is equal to 0, which means that z cubed is equal to 0 or just z is equal to 0. And isa. Next is z squared plus 1 is equal to 0. So that is z squared is equal to negative 1. Square root nun is just square root of negative 1 or just simply positive and negative I. Okay, so therefore, ang kanyang singular point o kanyang singular points are 0 and 0, positive and negative I. Yun yung mga singular point niya. Okay, so therefore the singularities are 0. Lagay ko na lang So the singularities this is the singularities of z plus 1 over z cubed then z squared plus 1 are 0, I, and negative I. Okay, so yung singularities. So hoping naman na-gets mo na ano yung singularities na kasi importante yan dito sa next natin. Okay, so let's have this definition. So we have the residues. So when z0 is an isolated singular point, okay, so again, isolated singular point. Singularities ako ng singularities, no? Pero again, singularities okay ba siya? Pero okay na yan. Sige, singular point. So singular points are the singular points so the singular point of z plus 1 over z cubed times z squared plus 1 are 0, I, and negative I. Okay, next is we have the residues. So when z0 is an singular, when z0 is an isolated singular point, so again isolated, so nag-iisa siya. Okay, of a function f if there is a positive number r sub 2, so radius yan, such that f is analytic at each point z for which 0 is less than z minus z0 less than r2. Consequently, f has a Lorentz series representation. So kung napansin mo, ikaw ay, kunyari, yung singularities mo is meron kang 0, specific 0, tapos meron pang R2. So sabi nga niya, yung f has a Lorentz series representation. So ito nga importante dito. Yung ating residue, gagana, masasolve natin yung residue ng isang function o ng isang function if siya ay naka-form ng Lorentz series. So dapat, ang una nating goal is dapat ma-form natin na Lorentz series yung function. Okay, so sabi nga ito yung Lorentz series niya. So paano naging Lorentz series? Ito yung summation something dati. In-expand ko lang konti. Ito yung power series plus something ng pagiging Lorentz. Okay, for n is equal to 1, for n is equal to 2, for n is equal to n. So kung naalala nyo, yun. Okay, so naka-expand lang yung part na yun. So anong sabi? The integral can be obtained using this formula. So ang sabi, that is the integral f of z dz along the contour z. So instead of kunin natin yung integral niya along the contour z, although may mga method tayo para i-solve yun, what if ganito na lang gawin natin? Siya ay solvable using 2 pi I times the residue of f of z for z is equal to z naught, wherein z naught is the singular point ng ating function. So ano lang gagawin? Where, lagay ka lang dito, where residue ng f of z at z is equal to z naught is just equal dun sa b sub 1. So ano yung ibig sabihin? Hahanapin mo yung term nung ating Lorentz series na kung saan siya yung 1 over z minus z sub naught raised sa 1. Kung sino yung naka-raise sa 1, kung sino yung kanyang coefficient, ayun yung ating residue. So again, sa dun lang tayo sa 1 over. So again, hanapin mo lang yung something. Hanapin mo lang tong b sub 1 over z minus z naught raised to 1. Pag nahanap mo yan, therefore yung b sub 1, kung ano man yun, coefficient siya yung ating residue. So kaya ako nga pinapa-expand ng Lorentz series. So for illustration or for diagram, paano ba magiging itsura na ito? Suppose na ito yung ating graph. Okay, so suppose ito yung singular point natin na z naught, tapos napapaligiran siya ng contour, something na contour, itsura ng contour. For example, ito. Okay, so yun yung contour natin. Suppose yun yung contour, since isolated si z naught, pag isolated, singular point siya, so bilog lang siya. Then meron ditong r naught. So aware tayo na yung z naught na yan is pwede natin i-form as may radius of convergence. So ibig sabihin ng may kinuha ko yung radius of convergence o yung ganito, ibig sabihin ipo-form natin siya as power series. So kaya siya ginaganto. So instead na kunin natin yung integral ng function along dito sa loob, what if ganyan na lang? Gumawa tayo ng power series na kung saan may radius of convergence, na may circle of convergence rather. Okay, then nakapaloob sa kanya yung contour. So ayun yung isa sa concern, kailangan nakapaloob sa contour. So ibig sabihin dapat mas malaki siya dun sa ating kumbaga yung function na i-create natin, tapos together with its contour mas malaki dun. Okay, so for example, try natin. So ito lang importante. Ang importante lang dito is hanapin mo yung integrant, sundin mo yung formula na 2fi, nilagay mo residue of z is equal to z naught, tapos yung f of z. Yung f of z gagawin mong Lorentz series. Okay, again, ang gagawin mong Lorentz series. Pero syempre, before tayo mag-start ng ganun, ang gagawin mo syempre is i-graph muna, tapos i-check mo kung Lorentz series ba siya o makaka-form ba siya ng Lorentz series. Okay, so for example, so evaluate the integral of z squared sine 1 over z dz along the contour z, where c is the positively oriented unit circle with radius 1. Okay, so note na yung function natin dyan, yung f of z natin dyan, write ko na lang, no? So note na yung f of z natin dito is equal to z squared tapos sine over 1z. Okay, note na yung ating singular point dito, yung singular point dito is 0. Singular point is 0. So ito yung z naught natin. Okay, so kunwari ginrap ko siya. Sir, ano ba mag-iitsura pag ginrap yan? Pag ginrap, I think ito siya. Drawing lang ako dito. So drawing ako dito ng bilog. So kasi ay singular point sa 0. Okay, then may radius 1 daw. Okay, since may radius 1 siya, create ako dito ng circle somewhere kasi sa contour C. So create ako ng circle. So, ito yung contour. Ito yung 1. Okay, so kung napapansin mo, yung z somewhere nasa loob. Annulus siya. Bakit? Ito yung 0 tapos something na ganun. So, kung mapapansin mo yung domain niya is 0 less than modulus of z less than infinity. Less than 1 rather. Okay, so ibig sabihin Lorentz siya. Kasi napapalibutan siya ng dalawang region, ng dalawang r o ng dalawang number. So that is 0 tapos yung 1. So may annulus akong na-form. So meaning, mapuform natin ng Lorentz series tong z squared sine times 1 over sine 1 over z. Okay, so using this definition, the integral, so solve ko na lang ha. The integral along the contour z of z squared sine 1 over z dz is just equal sa 2 pi I. So yan yung importante. Si 2 pi I formula, then residue. So we have the residue of z is equal to 0 because 0 is singular point natin. Then ilalagay ko dito yung ating function, yung function na z squared sine ng 1 over z. So para hindi nakakalito. Okay, so I think mas maganda to. So ito sa ibang videos kasi ito yung ginagamit, sa ibang book din ganyan din. So i-enclose natin siya as open and curly braces or bracket rather. Then ang goal natin is i-obtain yung Lorentz series representation nito. Okay, so ay importante dapat expansion. To be honest, dapat expansion. Pero kung gagawin natin yung compact form muna niya. So I think ito yung mangyari. This is equal sa 2 pi I residue of z is equal to 0 of z squared, tapos this is summation for n is equal to 0 up to infinity ng 1 over z. So since 1 over z siya, so kung naalala ko, this is negative 1 raised to n, tama, tapos ito ay 1 over z raised sa 2n plus 1 over 2n plus 1 factorial. Okay, so meaning sa ilalim yung z raised to 2n plus 1 times z squared. So i-add ko na yun ha. Ito kasi ilalim, z raised to 2n plus 1 times z squared. So nasa taas yung z squared. So magkakaroon ng that is 2 minus 1, that is 1 lang sa ilalim. So meaning that is z raised to 2 minus 2n plus 1, so that is 1. Okay, then ini-negative pa ilalim. Wait, check ko sa ilalim. That is z raised to negative 2, aangat z raised to negative 2, negative 1 rather. Okay, so para di ako malito, ganito na lang. This is 2 pi I residue z is equal to 0 ng, ito ay summation for n is equal to 0 up to infinity ng negative 1 raised to n. Yung z squared papasok ko muna dito. Yung 1 raised to 2n plus 1 wala na yan. Okay, then all over z raised to 2n plus 1 tapos 2n plus 1 factorial. Okay, so paano magiging simplified form? Nalito-lito na ako sa exponent, no? So z squared bababa yan, z raised to negative, tama, tas i-add natin doon. So ang simplified form niya is 2 pi I, then the residue z is equal to 0 ng summation for n is equal to 0 up to infinity ng negative 1 raised to n over z raised to 2n minus 1, then 2n plus 1 factorial. Okay, next, since na-simplify ko na, I think pwede ko nang gawing expansion yan. Okay, so expand ko na. So sure naman ako na siya ay Lorentz. Bakit? Nasa ilalim yung z raised to something. Okay, since nasa ilalim siya, alam ko siya ay Lorentz. Tapos yung kanyang yung z minus z naught niya is 0. Okay, z minus 0 is z na. Yung z natin is z minus 0. So okay lang. So, yun yung concern nito. Yung z is equal to 0, dapat z minus something siya. Z minus z naught siya. Okay, then this is equal sa, yung expansion nito is 2 pi I. Okay, then yung residue ng z is equal to 0 up to infinity. So, expand natin yan. For n is equal to 0, 1 yun. Tama. Tapos dito is negative. So, 1 yun. Negative 1 raised to 0 is 1. Z raised to 2 times 0 times negative 1 is z raised to negative 1. So, obviously, z raised is ito. Kasi 1 over z raised to negative 1. Or ganito na lang. 1 over z raised to negative 1. Okay, so obvious na siya ay aangat. Tapos yung 2 times 0 plus 1, that is 1 factorial. Wala na yan. Next, for n is equal to 1, that is minus 1 over z raised to 1, no? That is z raised to 1. Tapos, 2, that is 3 factorial, no? I think this is times 3 factorial. Then, plus 1 over z raised to 3. I think this is z raised to 3. Tapos, 5 factorial. Okay, then I think minus, then that plus. So, sir, pwede ganyan? Yes, pwede na. Kasi nakikita ko na yung ating residue, something. Okay, so kung napansin mo, dito, yung b sub 1 natin dito, note na yung b sub 1 natin dito. So, yung b sub 1 natin, yung ating b sub 1 dito is equal to negative 1 over 3 factorial. O, sir, bakit, sir? Since meron akong negative 1 over 3 factorial multiplied by 1 over z minus 0 raised to 1. Okay, n yun, no? Yung z raised to 1 na yun is z minus 0 raised to 1. Tapos yung kanyang coefficient is negative 1 over 3 factorial, in which that is negative 1 over 6. So therefore, the residue is just equal sa, this is just equal sa 2 pi I, okay, multiplied by, this is negative 1 over 6. Or simply, this is negative pi I over 3. So, therefore, ito yung kanyang integral. Okay? So, ganun siya kasimple. So, again, expand mo lang. Hanapin mo yung z minus z naught raised to 1. Kung ano yung coefficient niya kasama yung sign, kunin mo yun. Okay? So, therefore, ayun yung kanyang integral. So, check ko lang kung parehas tayo ng sagot sa book. So, ayun naman, parehas tayo ng sagot sa book. Okay, so for number 2, show that the integral along the contour of exponential ng 1 over z squared dz is equal to 0 when z is the same oriented circle for z is equal to 1. So, similar yung graph. Okay, so obviously siya ay Laurent. Okay, so similar yung graph, obviously siya ay Laurent. Parehas lang dyan. Okay, so asa pinagkaiba dito, prove or show. So, meaning proving to. Okay, so ito yung proof. So, ito yung proof natin. Okay, note that the integral of z, so exponential ng 1 over z squared, yan kasi ibig sabihin yan, dz, can be obtained using 2 pi I times the residue of z is equal to 0 of e raised to 1 over z squared. Okay, then write natin yung kanyang Lorentz series expansion o yung kanyang compact form sa loob. So, this is just equals to 2 pi I, then residue ng z is equal to 0 ng, ito ay summation ng z raised to n over n factorial. So, this is summation for n is equal to 0 up to infinity 1 over z squared raised to n over n factorial. Okay, so kung papansin mo, that is z raised to 2n sa ilalim natin nilalagay. So, obviously, this is just equal sa 2 pi I residue for c is equal to 0 ng summation for n is equal to 0 up to infinity ng 1 raised to n is just 1 over z raised to 2n tapos n factorial. Okay, then try to expand yung ilalim. So, that is 2 pi I, then residue ng z is equal to 0, and that is, for n is equal to 0, that is 1 over z raised to 0, that is 1. Okay, for n is equal to 2, that is plus 1 over z, for n is equal to 1, that is 1 over z raised to 2, then 1 over 2 factorial, so that is 2 raised to z to the 4th. Okay, plus 6z to the 6, then plus dot plus, ganyan yung kakalabasan. So kung napapansin mo, ano yung base of 1 natin dito? Okay, so ang base of 1 natin dito is 0. Note that base of 1 is 0 since 0 over z siya something. Wala kasi tayo nakikita na 1 over z. Napansin nyo, wala tayong nakikita 1 over z. Since hindi natin nakikita, automatic 0 siya. Okay, so ito z minus 0 natin. So para makita nyo, raised to 1. Okay, so wala, hindi mo siya nakikita, pero ganyan yung form niya. So b1 is equal to 0. Therefore, this is equal sa 2 pi I times 0, which is equal sa 0. So therefore, this is done. Kasi yun yung kanyang sagot. Okay, so ganun kasimple yung gagawin dito sa mga residue. So, pag proving, ganyan ang gawin mo. Okay, next. Number 3. A residue can be also used to evaluate the integral of dz over z minus z to z minus 2 raised to the 4 or raised to 4 along the contour C, where C is the positively oriented circle, z minus 2 is equal to 1. So, paano ba yung magiging tsura ng graph natin dito? Okay, so, positively contour, no? So, kung napansin nyo, paano ba yung magiging itsura ng drawing? Check ko lang ha. Okay, so I think ito yung magiging itsura ng drawing. Papaisip kasi ako sa drawing eh. So, kailangan nyo lagi drawing kasi kailangan natin ma-check kung siya ba ay Laurent or makaka-form ng Laurent. Ito kasi yung importante. So, z minus 2 is equal to 1. So, center siya at z at 2. So, meaning, count tayo ng 2, no? So, kunyari, ito yung 1, tapos ito yung 2. Okay, so, meaning, dito yung ating singular point, kasi singular point niya si 2. Tama, ay singular point niya si 2. So, bilugan ko to. So, singular point siya. Tapos, yung z minus 2 na yan, may radius 1. So, tama lang naman ito yan. So, napansin mo, Laurent siya. Okay, ngayon, since Laurent siya, gagawa tayo ng mas malaking power series kasi yun yung sabi. Ito yung contour niya, yung yung nasa bilog na yan. Okay, so yun yung contour C natin. So assuming ito yung contour C natin. Okay, so gagawa pa tayo mas malaking bilog kasi nga gagawa tayo ng kanyang power series. So ayun yung ibig sabihin. Bakit ako naglalagay ng ganito? This is just to form a Laurent series or nung kanyang McLaurin power series. So again, alam natin ito yung kanyang z is equal to 2. So, yung singular point natin is 2. Okay, so ang goal natin, dapat z minus 2 lagi yung lalabas. So, kanina, bakit 0? Z minus 0 yun, kaya z lang. Ngayon naman, ang goal natin, dapat z minus 2 lahat nung term. So, ito medyo mahirap yung gagawin natin. Kasi, meron tayong z minus 2, problema pa si z. Okay, kailangan si z, maging z minus 2 rin yan. So, isa rin sa problema natin, dapat maging z minus 2 yan. So, check ko lang, paano ba natin didiskartehan yung ganyan. So, I think pwede kong gawin ganito. Ito na lang, no? We have the integral. Or, ganito na lang. Doon ko na mismo sa solution lalagay. Yung 1 over z times z minus 4 ay minus 2 raised sa 4. This is equal sa 1 over z minus 2 raised sa 4. Okay, times 1 over z. Okay, ang concern ko dapat yung z maging magkaroon ng z minus 2. So, paano siya magkakaroon ng z minus 2? So, I think pwede natin siyang gawing paano ba magkakaroon ng z minus 2 to? So, kailangan natin ng negative 2, no? So, I think pwede ako mag-add ng 2 plus c, 2 plus negative 2. So, I think pwede kong gawin to. Check nyo na lang. This is 1 over z minus 2 to the 4th multiplied by 1 over, gagawin ko tong 2 minus z minus 2. So check nyo lang. Or I guess plus dapat to. Sorry. Ito ay plus. Okay. Tapos, yan, pwede na yan. Lalabas ko na lang dyan mamaya yung 1/2. So, I think pwede na to kasi may z minus 2 na ako. Okay. So, I think ready na tayong hanapin yung kanyang Maclaurin series. Yung kanyang Taylor series representation. So, solve na natin. The integral along the contour C of dz over z minus 2 raised to 4 is equal to 2 pi I times the residue for z is equal to 2. So again, for z is equal to 2. So meaning, ito yung declaration na siya ay z minus 2. Dapat yun nakikita natin. Susulat ko na yung simplified form natin na nilagay. That is 1 over c minus 2 raised to 4 multiplied by 1 over 2 plus z minus 2. So, ang goal pa natin, dapat mailabas natin yung negative somewhere or somewhat. Tama kasi, eto, may expansion to or may representation to, pero 1 over 1 minus z lang yun. Yung z raised to n, kung naalala nyo. Kailangan maging 1 over 1 minus zn something, or 1 over 1 minus something, para magamit natin yung summation ng z raised to n. Okay? So, dito, magpapactor out ako ng negative ng, I think, ng 1/2, tapos, yung positive gagawin ko negative, dalawa. So, check nyo lang yung gagawin, sir. This is equal sa 2 pi I residue for z is equal to 2. Then summation, that is 1 over z minus 2 raised to 4 multiplied by, lalabas ko yung 1/2. Okay, this is 1/2 multiplied by 1 over, magiging 1 na lang to. Tapos lalabas ko yung negative dito. Tapos may negative ng z minus 2 over 2. So, check nyo yung ginawa na, sir. So, pag minultiply ko yung 2 dito, that is 2. Tapos 2 times dun, mawawala, cancel. Tapos yung negative kasi that is positive. Kaya ako kinancel. So, meron na akong z minus 2. Ito na yung mismong z ko. So, pwede na ako magkaroon ng power series representation sa part na to. Tapos, konting manipulate na lang using tong mga to. Okay, so proceed na tayo doon sa power series representation niya. That is equal sa 2 pi I. So hoping din na kasya. Residue. Z is equal to 2. Then, this is 1/2 multiplied by 1 over z minus 2 raised to 4. Tapos, summation for n is equal to 0 up to infinity ng z raised to n. Pero yung z natin is negative z minus 2 over 2 raised sa n. Okay, so yung z minus 2 yung titira natin dyan. So z minus 2 raised to n, ititira natin. Okay, tapos yung negative 1/2 raised sa 2. So may negative 1 raised to n dyan. Tapos may 2 raised to n pa tayo dyan. So kasi negative 1 raised to n tapos 2 raised to n sa ilalim. Okay, so mangyari, this is 2 pi I residue of z is equal to 2 ng summation ng 1/2 multiplied by 1 over z minus 2 raised to 4. So gagawin ko yung gagawin, that is summation for n is equal to 0 up to infinity ng negative 1 raised to n, ayun yung binabanggit ni sir, over 2 raised to n, tapos z minus 2 raised to n. Okay, then ipasok pa natin itong 1/2 saka z minus 2 dun sa loob. Okay, so para makita natin. Z minus 2 raised to 4 sa loob. So this is simply equal sa 2 pi I residue for z is equal to 2. Then this is equal sa summation for n is equal to 0 up to infinity. Then negative 1 raised to n. Tapos z minus 2 raised to, nasa ilalim to, so n minus 4. Okay, all over 2 raised to n plus 1 kasi nasa ilalim, madadagdagan siya. Kasi 2 raised to n yun, tas 2 raised to n plus 1 siya. Okay, next is expand na natin yung nasa loob. This is just equal sa 2 pi I times the residue of z is equal to 2 nang expand natin for n is equal to 0, that is 1. Okay, so for n is equal to 0, positive siya, dito is 2. So 1 half, so magkakaroon tayo ng 1 half tapos times z minus 2 raised to negative 4. Yan yung una. Yan, for n is equal to 1, that is negative. So negative 1, 2 raised sa 2. Tama. Tapos z minus 2 raised sa negative 3. Okay, for n is equal to 2, that is positive. That is plus 1 over 2 raised sa 3. Tapos z minus 2 raised sa negative 2. Okay, so hindi pa natin yung negative 1 kasi yung 1 over z raised to sa negative 1. Then plus, so yun, sorry, minus 1 over 2 raised sa 4 ng z minus 2 raised sa negative 1. Then plus dot minus. So pwede ko na hindi sulat. Okay, note na ito na yung part na yon. Okay, note na yung b sub 1 natin. So note that b sub 1 is equal to negative 1 over 2 raised to 4, or simply negative 1 over 16. Kasi yung ating term na ganito, since we have the term negative 1 over 16 tapos z minus 2 raised sa 1. Okay, so ayan yun. Okay, so that is negative 1 over 16. So applying that definition, this is just equals to 2 pi I multiplied by negative 1 over 16, or just this is equals to negative pi I over 8. Okay, so therefore ito yung kanyang sagot. So napansin mo na retain kay z minus 2, z minus 2, z minus 2. Okay, so ganun yung application ng residue. So again, residue pa lang siya, hindi pa siya yung Cauchy residue theorem. Iba pa yung Cauchy residue theorem kasi what if naman marami siyang singular point. Okay, so ito kasi inassume natin na isa lang yung singular point niya, which is 2. Although dalawa singular point niya, may 0 pa. Okay, so pinix natin na dapat isa lang yung singular point niya, which is 0. Which is 2. Okay, so thank you for watching. So hoping na naintindihan mo at natuwa ka kasi medyo application na integral tapos power series.